Well, good morning to one and all present here. I'm Lavanya Elangovan, your science educator. Right? So, welcome to Be Learning. How are you all? Good? Fine? Am I audible? Is my voice clear? Is my video clear? Correct? Shall we proceed? Give me one thumbs up. I'll just proceed with the session. Fine? Good. All right, guys. So, what are we actually discussing in this particular session? Hmm, correct. So we are learning about the structure of atom, right? So before that, tell me, like what we learning is, right? We learning is an online education platform where we give quality education for all students like you. Here at Vista's Learning, we help students like you to stay on schedule, value their time, and also excel in their academics. So, to subscribe to our channel and stay connected with us, come visit our application where we have PDF notes for you. We've got question answers, assessments where you can actually solve a lot of questions and answers, numerical problems, and a lot more. You will also have an opportunity to chat with the teachers then and there to clarify your doubts. It's right, school, right? Good. So do share it with your friends, family members, and relatives because someone out there will have the access to quality education. Correct? So good. So having said that, let's start today's session without any further delay. So what are we discussing today? It is all about structure of atom. Okay. So what is an atom? It's a basic structural unit of everything. We can say like all matter, irrespective of their physical state, it is being made up of atoms. Right? So we are actually discussing about what is an atom, what is it made up of, or what all the components that is exactly present inside the atom. Alright, so that is what we are exactly discussing in this session. Fine, good. So now, so basically whenever we say about atom, this is what comes to your mind. Correct? So anywhere you see, we'll get this particular image of an atom where something in the nucleus we'll have, and around the nucleus something else is actually revolving, right? So what are these? One second. Okay. So what is this? Or how did scientists came to one particular conclusion like, okay, atom is exactly like this? How did they figure it out? So that is what we are exactly looking in this session, right? So one second, I'll just pick my pen. Okay, yeah. So here when we see, this is the nucleus, which you know very well, right? It's already written, but still I'm writing for your reference. And here this is electron, which has negative sign, and this is proton, which is always positive, and neutron, it is neutral actually. Correct. So these things you know very well. So how did scientists come across? How did they bring to this particular decision? Like, okay, atom is like this. They didn't come like all of a sudden, okay, fine, this is an atom, this is how it is. No, step by step. So the first scientist who did a lot of research on this particular the structure of an atom, and he was J.J. Thomson. Correct? And he did not give the exact structure of an atom because there were a lot of scientists who were working on it, and his theory was something which we are a lot of possibilities for us to follow, or all the theories that we are following now, this was a foundation for it. Is that clear? So according to him, this is the entire structure of an atom for him. Okay, it is, we can say like it is a plum pudding model. Where can you see this entire orange color? So this entire thing is a positive charge. It's a cloud of positive charge in which the negative charges are actually embedded. The electrons are actually embedded inside the positive charge. Is it clear? Just like the plum pudding where you can find all those fruits and nuts being studded, right? So it is exactly like that. So that is why we call this to be a plum pudding model. Okay, so until another scientist came with criticism, this was to be, this is what they believed. Okay, it is made up of positive cloud and the electrons are actually embedded in it, or it is studded in it. Clear? So next, so today we'll be focusing on what was Rutherford's model of an atom. Right? So if we are, or if any scientist is coming with theses, obviously there'll be criticism like why, how, when, what, What all? So there will be a lot of questions arising to it. And that particular thesis should satisfy every single question arised. If it's not satisfying, then they'll look into another theory, like how to start or how to bring it and all those things they'll be looking at. Is this clear? So according to this Rutherford, who's Rutherford? First we'll look into him. So Ernest Rutherford, he is actually a physicist. He is actually and also a Nobel Prize winner. Fine. And he is also referred as the father of nuclear physics. Because the model that he gave for an atom is actually so good, which means we can, like, he differentiated the positive charges, he differentiated the negative charge. He said something else is also present along with it. So that is what Rutherford said. And based on Rutherford's model, different models or different structure of atom were evolved. And now whatever structure we are following, it's actually built by, you'll be studying like who actually built it, but you'll be actually studying like it is being built by John Dalton. Is that clear? Fine. Now we'll see like what did Ernst Rutherford said, okay, or formulated. So in order to figure out the structure of an atom, he had a lot of postulates. We'll be looking at one in each and every postulate, okay. So for that, to find out, he just used certain simple equipments, okay. First, the thing what you can see here, so this one is actually a alpha particle, okay. We'll write it alpha here. You know what is an alpha, right? So it is an alpha particle. And now he has actually put the source of an alpha particle inside a lead box. So through this opening, wherever here, there will be an opening through which the alpha particle will come out and shoot out. Okay. So this is going to go and shoot on a gold foil. Okay. So this gold foil is actually a very thin strip. Actually very thin strip, which means like it will have only 1000 atoms. Okay, so that much small, that much thin. How much ever thin it is, we can actually get a clear picture of an atom, right? So that is why they preferred a very thin gold foil, hardly of 1000 atoms. Is that clear? Correct? Okay. So now when this alpha particle strike on this gold foil, it is obviously going to strike the atoms of the gold foil. Atoms of gold atoms, right? So according to his perspective, according to J.J. Thomson's model, this should penetrate easily and come out. Right? So whatever rays is being sent, every single ray must penetrate and come out. Alright? So there should be only one direction. It should be unidirectional. That is what his perspective was. Okay? So why did he do it? Just to verify J.J. Thomson's model of an atom. Okay. But for his surprising thing, he was actually astonished with the results. I'll tell you why. See, I said like this particular, what is this? The ray, the alpha ray or the alpha particle must penetrate into the gold foil and come the other side. Yes or no? So when it is coming the other side, how will you know that something has come or it has passed through? It can also get absorbed, right? It can also get reflected. We don't know. We just wanted to just check it, okay? So how are we going to check? Very simple. See, for example, you would have studied this in your 6th standard. For a shadow to form, you need a light source, right? And you need an opaque object and you need a screen. Yes or no? Only then the shadow of this opaque object will be formed here, correct? So you need 3 different things: a light source, an object, and then a screen. Same thing here. Here we are just checking the presence of atom. What is exactly present inside an atom? So for that, we've got a light source. We've got an object, the gold foil, the very thin gold foil. And here we need a screen. Correct. So here, instead of having a screen like this, he thought of having a screen in a circular pattern like this. Okay. That is actually a fluorescent screen. Just like the cathode ray experiment, where the one end it was a fluorescent screen, right? So once the particles strike on it, it will glow. So similarly, here also it should be a fluorescent screen. When the particles strike on it, the screen must glow. Is that clear? So just have these three things in mind: the light source, the gold foil, and the fluorescence screen. Correct? Okay. So we'll move on. Is this clear? Clear, right? Okay. So here what happened? You can actually look at this one very carefully. So this is the source, high beam source. And alpha particles, they are having a higher mass. Higher mass when compared to the mass of the gold atom. Since the mass is too much, it has to penetrate and go. That was the concept. Okay. Because everybody thought like this atom is just like a plum pudding model where it is of a positive sphere and electrons are started here and there. That is what they thought. Clear? And now to his, like when he, after the, as a result or as an inference, what happened is like, so many particles actually passed through. Let me take another color. Wait. Okay. So can you see this? Okay. So now when it came out, a lot of particles, it actually passed through it. Okay. Some rays actually deflected to some extent. To some extent, it deflected. For example, I just tried it here. So here, this is a light source. Again, I have to change the color. Wait. Okay. So this is a light source, and from the light source, something is going. We'll just imagine. And this is a foil. Okay. So this is striking on, we'll just keep like one atom. This is striking on one atom. Okay, we'll just. So if it was a plum pudding model where complete positive sphere studded with electrons, it has to pass directly outside and it should reflect, like it should be, the screen on the other side must glow. Yes or no? Correct? So, but instead of that, to some extent, when the ray came like this and it struck somewhere here and it got deflected. Somewhere it got deflected, somewhere it got deflected like this to a very small degrees of angle. And to his surprise, some got completely rebounced in this way. It was completely rebounced. Can you understand this? I'll tell you again. Just look at this image. Okay. So in this image, when you see, just look at it very, very carefully. So this is a ray, right? So this ray is penetrating directly here. Actually, all the rays must penetrate straight, in a straight path, unidirectional. It has to be unidirectional. But here when you see, these rays are deflected. They are not straight. So this is straight, but these four rays are deflected. To some angle it is deflected. And when you look at these two rays, it is completely rebound or reflected. Yes or no? Correct? Yeah. So how did this happen? So from this, he came to a conclusion that most of the fast moving alpha particles passed straight through the gold foil. So that is what happened. Okay. When we are comparing around 1000 rays, they just passed through the foil. Number 2. Some of the alpha particles were deflected by the gold foil by small angles. The four angles that whatever we saw. The third, surprisingly, 1 out of every 12,000 particles appear to rebound or reflect. Somewhere it has struck something very hard and it has, it has rebounded. Okay. Is it clear? Fine. Shall we proceed? Correct. So just have these three observations because this is really very, very important. I'll tell it to you again. The first, most of the fast moving alpha particles pass straight through the gold foil. Okay. And number 2, some of the alpha particles deflected to some small angle. And number 3, it was like for every single 12,000 particles appeared to rebound. Is that okay? Is that clear? So here when you see in this, all this 3, we'll just put it like 1, 2, 3. So here maximum particles passed through. We'll keep for 5. Okay. So maximum particles passed through. And here some particles deflected. We'll keep this to be 2. Okay. And this one, this is very, very small, only 0.1. Only some got rebounded. So from this, what can we infer? So it is not the exact full positive spheres having the electrons embedded. No, it is not exactly like that. It is something else. So he inferred a very good observation. I'll just tell you. So what he inferred was like most of the space inside an atom is empty because the alpha particles pass through the whole foil without getting deflected. So if we consider this to be an atom, you know very well this is a hydrogen atom. We'll keep this, okay? This is something. And here we'll just keep this to be an atom. So when the alpha particles came, here it is so empty, so it went. So again, the another ray, it just passed through the atom. And when we are talking about this one, somewhere if this ray has struck in this corner, it would have got deflected. Correct. The same thing the other side also. Here it would have struck, and again from here it would have got deflected. So when a ray strikes directly here, only then it will get rebounded. Correct? Now is it clear? So just have this to be a pattern. So the first inference was like most of the space inside an atom is empty. That is why most of the alpha particles passed through the gold foil. Okay, without getting deflected. Number 2. Very few particles deflected from their path, indicating the positive charge of an atom occupies very little space. Because alpha particle is of negative charge. Okay, so since it is having a negative charge, that is why it has got deflected. So for example, if we bring like poles of a magnet, they'll repel. So no, so just like that, alpha particles, they have negative charge. So once they are coming and striking this particular atom where the positive charge is there, since the positive charge is there, it has got deflected to a small angle because it has struck only the surface of it. And the third inference will be the cause for the exact rebounding. Okay. Very small fraction of alpha particles were deflected at 180 degree, indicating that all positive charges and mass of gold were concentrated to a very small. So from this we can infer. So when you just look at this, just look at this one. So only one ray in this, all these rays, one ray, it penetrates, tried to penetrate into the center of an atom somewhere. And when it tried to penetrate, it cannot go there because it is complete mass, dense mass of positive charges. And when a ray comes and strikes near the positive charge, since it is having a lot of negative charge just like that, it got repelled. It got rebounded. Is that clear? Oh, yeah. Alpha particle is positive charge. Since it is having a positive charge, it is getting repelled. Correct? So magnets will repel, right? North and north will repel, south and south will repel. So alpha particles have positive charge, so that is why they are repelling. If they are having a negative charge, they would get attracted, just like the cathode ray. Correct? Yes? Good that I remembered. Right? Good. So alpha particles, I repeat, alpha particles are having positive charge, and that is why they are getting repelled. Clear? Good. So now, so next. So what is the features of a nuclear model? Number 1, there is a positive charge center in the atom called nucleus. Nearly all the masses of atom resides in the nucleus. Is that clear? Correct? So that is what they inferred, the first feature. So second, electrons revolve around the nucleus in circular path. Number 3, size of the nucleus is very small as compared to the size of an atom. Is that clear? So here when we are looking at the third point, size of the nucleus. So if we consider this to be an atom, the size of the nucleus here in the middle is very, very small. Okay. And the electrons, they are something called negative charged subatomic particle, right? The electrons. So they are revolving around the nucleus in their own orbits, circular orbits. And the first one was, there is a positive charge center in the atom, and since it is in the center, we call that to be a nucleus. Nearly all the mass of the atom resides in the nucleus only. So because electrons are very, very negligible in size. Okay, so far they haven't thought about neutrons. They say like positive charge, negative charge only. So how is a atom getting its mass? that will be listening, or that will be studying when Chadwick, a person called scientist called Chadwick, who discovered the presence of neutrons there. Clear? So now, every single thesis will have its own drawbacks. Okay? So likewise, there are certain drawbacks for this Rutherford's model of an atom also. So what are those drawbacks? I'll tell you. See here, according to this one, according to him, he said like it is having a nucleus in the middle and the electrons are actually revolving around it, right? So this particular revolving around, and any object when it is having rotating, revolving around in a circular path will gain its acceleration. Yes or no? So it will have its acceleration of its own because it is continuously revolving just like this. When it is continuously revolving, some movement is done there, acceleration is happening. So as a result, this electron will try to lose its energy. Yes or no? So as it is trying to lose energy, one day what will happen? It will lose all its energy, it will fall back into the nucleus. Correct? But it is not happening like that. All the atoms are stable now. Since every atom is stable, we can actually have matters around us. Correct. So how to make this electron stable, or what is making this atom stable? Though the electrons are revolving around its own orbital, like how many electrons are there, we don't know still. What is the number of protons? We don't know. What is the mass of an electron and proton? We don't know. So these are the, without having all these assumptions, we are just looking at the perspective of the different scientists. Is that clear? So according to this particular theory, this was one of the drawbacks. When an electron is revolving around in circular path, or any object revolving around in a circular path will have its own acceleration. So that acceleration, or because of that, or because of the continuous movement, at one point of time the electron must lose its energy and fall back into the nucleus. If that is happening, the atom cannot remain stable at all. But the stability of an atom is maintained. That wasn't explained by this Ernest Rutherford. And in order to explain that only, we've got another scientist, Niels Bohr. Okay. So Niels Bohr model of an atom. So what is according to Niels Bohr? So he is the one who gave the electronic configuration. We'll study what is electronic configuration, the different shells and all those things. Okay. So now, according to him, only certain special orbits known as discrete orbits of an electron are allowed inside the atom. And number 2, it is while revolving in discrete orbits, the electrons do not radiate energy. This is something which we have to note down. So the electrons are not liberating any energy, radiating any form of energy when they are in their own orbit. When they actually skip from one orbit to another orbit, then the loss and gain of electrons, loss and gain of energy can take place. But unless and until it is having, or it is revolving, rotating in its own discrete orbits, the electrons are not going to lose any sort of energy in any form. Clear? Clear? So according to him, this is a model of an atom. So this center part is a nucleus, where now only positive charges are there, because we haven't talked about neutrons still. And here these are the electrons which is having the complete negative charge. Okay, so now when you see these are the orbitals. Okay, so we can actually, he named them to be M, N, K. Okay, we can also say this to be N equals 1, N equals 2. We'll study about these in our next session, but still I'm just telling you an introduction overview. Okay, so here these electrons, when we are looking at the first orbital can accommodate only 2 electrons. The second orbital can accommodate only 8 electrons. Okay, third orbital we'll have subdivisions actually inside. The maximum is 8, but here it will be 18, but still we'll have the bifurcation. That you don't worry, I'll tell you what it is, 18. Okay, so we'll be having different shells. Actually, sorry, excuse me. Inside an atom, we'll have different shells. M shell, N shell, K shell. So there'll be a lot of shells inside an electron. Inside an atom where the electrons are revolving. So when this electron is revolving in its own orbital, discrete orbital, it is not going to radiate any energy. When this electron is escaping out, then it will liberate, or then it will radiate some sort of energy. Is that clear? Fine. So this is how this atom is being stable. But stability of an atom, don't worry, we'll study, because we know this concept of ions also, right? Where they share the electron, they take it back, they donate it, right? So that one we know, like, which actually explains us how an atom is stable. But don't worry, we'll be studying about all those things. Clear? Fine. So yes, my dear children, we've come to the end of this session. Okay, so if you just like it, don't forget to like it, share it, and subscribe it. So unless and until I meet you in my next session, this is Lavanya Elangovan signing off from V Learning. Bye bye. Take care.